Once again, hearty welcome to Answers to Questions for Revision, Class 12 Mathematics. At this video, 15 questions comprising MCQ, assertion and reasoning, short answer, very short answer, long answer, and case study questions are compiled from selected topics. At this video, the topic selected is application of integration and differential equation. Let us move on to question number 1. The area of the region bounded by the curve y is equal to mod x minus 2, x is equal to 1, x is equal to 3 and x-axis. We have to first recollect the formula. The formula for area is integral a to b y dx, because it is y is equal to f of x is equal to 1, x is equal to 3 and x-axis involved. Therefore, it is 1 to 3 mod x minus 2 dx. But modulus is having a property. It is a negative for mod of the value less than 0 and it will be positive for mod of the value greater than 0. But this is the mod x minus 2 values. It is x minus 2 for x minus 2 greater than 0 and minus of x minus 2 for x minus 2 less than 0. What is the meaning of it? X minus 2 for x greater than 2 and minus of x minus 2 for x less than 2. But we have to split the integral into 2 from 1 to 2 and 2 to 3. In 1 to 2, it is minus of x minus 2. From 2 to 3, it is plus x minus 2. By making use of one of the properties of definite integral. We will integrate it now. And we are substituting upper limit minus lower limit. And we are getting the answer as 1. Therefore, option D is correct. Let us visualize the graph of it, because sometimes they may ask you to draw the graph of it in the exam also. So this is the graph of mod x minus 2. And at 2 comma 0, it is having on the right side and left side. You are very well seeing that there is a area on the left and area on the left, 1 plus half plus half. Therefore, the answer is 1. The area enclosed in the first quadrant and bounded by the circle x square plus y is equal to 4 and the lines x is equal to 0 and x is equal to 2. We know the formula. Area is always a to b y dx for this, because x is equal to 0 and x is equal to 2 is given. Therefore, from 0 to 2, it is in the first quadrant only. Therefore, simply we have to find 0 to 2 y dx. Now, what is y from the given equation? It is square root of 4 minus x square. Therefore, integral 0 to 2 root 4 minus x square dx. We have to make use of the formula for a square root of a square minus x square. X by 2 into square root of a square minus x square plus a square by 2 sine inverse x by a. Here a is equal to 2. We are substituting the values. Upper limit sine inverse 1 is pi by 2. Sine inverse 0 is 0. Therefore, 2 into pi by 2, the answer is pi. Now, let us visualize the graph of it. This is the graph of this area. It is in the first quadrant, bounded by the line x is equal to 2. That is a line parallel to the y-axis, and it is in the first quadrant, and the area is 3.14. Maybe approximately that is pi. Let us go to the question number 3. The degree of the differential equation is. Now, you may be tempted to directly write the degree of the differential equation. But remember, degree of the differential equation can be visualized only when it is expressed as a polynomial in derivatives. Now, let us try to express it as a polynomial in derivative. Both the sides we have to square it, because it is power 3 by 2 not allowed. It will become 1 plus dy by dx whole square. The whole cube is d square y by dx square. Now you visualize it. Highest order derivative is second order and its exponent is 2. Power is 2. Therefore, it is the order of differential equation is 2 and degree is equal to 2. Therefore, the answer C is 2. Now, these types of problem you should be a little bit careful. The given differential equation to be expressed as a polynomial in derivatives, then we have to find out its order and degree. Question number 4, integrating factor of. Whenever this problem integrating factor comes, be careful. We should be a bit careful. We have to check out whether it is of the type dy by dx plus py or dx by dy plus rs. That is ry. That we should be a little bit careful with that. For this problem, the power of y is 1, but the power of x is more than 1. Therefore, we have to divide the whole equation by x. Then it will become dy by dx minus y upon x is equal to x power 4 minus 3x upon x. Now you just compare it with the general form of linear differential equation. Dy by dx plus py is equal to q. Power of y is 1. Now p is minus 1 by x. Q is x cube minus 3. No problem. Integrating factor is e power integral p dx. E power integral minus 1 by x. The word is minus log x. Now please don't get confused by directly writing e power minus log x is minus x. Let us check out. It is e power log of x power minus 1, which is e power log of 1 by x. Therefore, the answer is 1 by x. Be careful with this. Okay, well. Let us go to question number 5. The solution of the differential equation is. Now remember, normally whenever we are writing the solution, we will take the c as per our convenience. Let may be either c or log c as per the situation. But here you should be a bit careful because the final solution is given to you. Let us try. Now we have to write dy by dx, dx by x plus dy by y is equal to 0. Keep dy by y on the left hand side. And now you can make use of it already. It is variable separable is over. Do the integration. Log y is equal to minus log x. Both integration are coming in log. Therefore, take the constant also as log c. Therefore, log x plus log y is equal to log c. Log xy is equal to log c. Therefore, xy is equal to c is the answer. Okay. Therefore, you should be a bit careful whenever the final answer. Suppose if this question is asked for you to solve, you can directly write it as log x plus log y is equal to c and then come back. But this solution is given to you. Therefore, you have to take constant as log c. Let us go to question number 6. Assertion is area of the region enclosed by the curve y is equal to x cube and the line y is equal to 0 and y is equal to x is 12. And the reason is a formula for finding the area of the region is given. Well, let us now try to check out the assertion. Now, this is area enclosed by the curve and the line y is equal to 0 and y is equal to 8. Therefore, the formula is integral c to d x dy. X dy. Let us try to get x from the equation. It is y power 1 by 3. I am doing the integration from 0 to 8. I am getting the answer as 12. Because all of you know 8 power 4 by 3 is 8 power 1 by 3 power 4. Therefore, 2 power 4, that is 16. Therefore, you are getting it as 12. Therefore, assertion is true. But you see, the reason is given, but it is the formula for the other one. That is the area enclosed by the curve y is equal to f of x on the x-axis. Therefore, reason is actually true, but it is not used to prove the assertion. Therefore, both A and R are true, but R is not the correct explanation of A. Fine. Now, let us try to visualize the graph of it because it may be asked in the exam for 2 marks. This is the region enclosed by the curve y is equal to x cube and the line y is equal to 8, which is parallel to the x-axis. Well, go to the question number 7. The integrating factor of the differential equation given, and the reason is they have given the formula to get the integrating factor. Let us go to the assertion now. Now we will take it. Now I think all of you know that the coefficient of dx upon dy should be 1. Divide throughout by cot y, it will become x into tan y. Therefore, compare it with the formula dx, that is a general form of differential equation, linear differential equation. Dx upon dx by dy plus rx is equal to s, where r and s are functions of y. Okay, now I think r is equal to tan y and q is equal to secant square y by tan y. We are not worried about that right hand side. Now we are worried about only about the integrating factor e power integral r dy, which is e power integral tan y, which is log secant y. Therefore, it is secant y. Therefore, assertion is true. Let us go to the reason. The reason is given for the linear differential equation of the form dx upon dy plus rx is equal to x. Integrating formula is given. Therefore, reason is also true and it is used to prove the assertion. Therefore, both A and R are true and R is the correct explanation of A. Let us go to question number 8. We have to solve the differential equation. But be careful, whenever you find a differential equation, check out whether it can be done by variable separable or it can be done by homogeneous or it can be done by linear differential equation. Further, the better is first let us check out whether it is homogeneous. This is not homogeneous because a constant is there and the power of x is 1 and 2 and power of y is 1 and 2. Therefore, not homogeneous. It cannot be a linear differential equation because x and y are multiplied anyway. Now let us try to check out whether it can be done by variable separable. Now I am simplifying by taking y from outside from the last two terms. Now it has been factorized as 1 plus x into 1 plus y. Therefore, 1 plus y will come to the denominator, dx will go to the numerator. You can integrate now. The left hand side is log 1 plus y, right hand side is x plus x square by 2 plus c. Go to the question number 9. Solve the differential equation. Given that when x is equal to 1, y is equal to 1. Let us check out what type of differential equation it is. For that, let me try to find what is dy by dx. When I just trying to do it, now I am seeing that dy upon 1 plus y square and other terms along with x can be separated. Therefore, this is variable separable. Some of you may think that it is homogeneous. It is not homogeneous. It is variable separable. Now do the integration now. I am doing the integration. Therefore, left hand side integration is very simple. But the right hand side integration, it needs integration by substitution because the integral contains the differentiation of 1 plus log x. Maybe log x. I'm just doing it. It will become t dt. Therefore, t square by 2. Do the resubstitution. Therefore, tan inverse y is equal to minus of 1 plus log x the whole square by 2 plus c. Therefore, this can be written like this. But now this is a initial value problem, or you can call it as a particular solution problem. Therefore, it is given that when x is equal to 1, y is also 1. Put it now, you will get the value of c as pi by 4 plus 1 by 2 because tan inverse 1 is pi by 4 and log 1 is 0. Now you can put the value of c over there. Now you can leave it as it is. Otherwise, what you can do, if you want to write y is equal to what, then it can be written like this also. Tan inverse y is equal to pi by 4 plus 1 by 2 minus 1 plus log x whole square by 2. Therefore, y is equal to tan of the right hand side. Go to question number 10. Find the equation of the curve passing through the point if the slope of the tangent to the curve at any point is x y minus 1 upon x square plus x. This is a problem of differential equation where you have been given the idea of the differential equation in terms of words. Now let us see what do you mean by the slope. We know that the slope is of the tangent to the curve at any point is given like this, but the slope is nothing but dy by dx for a curve. Remember, slope of the tangent is nothing but derivative dy by dx. The dy by dx given. Let us try whether it can be done by variable separable. Yes, it can be done by variable separable. Now integrate both sides now. Now the left hand side integration is very simple. But the right hand side, what you have to do, you have to factorize it as x into x plus 1. And in the numerator, add and subtract x. Divide the integral into 2. The first integral will be 1 upon x. Second integral will be minus 1 upon x plus 1. Now you can do the integration directly. Now this integration can be done by integration by partial fraction also, or in the left hand side you can use that ax square plus bx plus c in the denominator. Anything you can do. But this is one of the shortcuts. Therefore, I got log of y minus 1 is equal to log of cx upon x plus 1. I have taken the constant also as log c because all the integration leads to log. That is why. Okay. Now this will help you to get the value of c quickly. Now the curve passes through the point 1 comma 0. 1 comma 0 should satisfy the curve. Therefore, we are putting y is equal to 0 and x is equal to 1. I am getting the value of cs minus 2. Therefore, this is the equation of the curve. Y is equal to 1 minus 2x upon x plus 1. Question number 8. Find the area of the region bounded by and the line. There are two equations given. Y is equal to 2x minus x square and the line. Let us see what are they. Now, this is a downward parabola and y is equal to minus x is a straight line. Therefore, this is a line through the origin. I am showing you the graph of it. Downward parabola and y is equal to minus x is the line through the origin. Now you are seeing that this is actually we have to find the area between them. Before we go further, we have to find the point of intersection where these both the curves meet. But anyway, sometimes you can get it from the diagram also. But well, I am putting one equation in the other and I am getting that x is 0 comma 3. Therefore, the curve and the line meet for x is equal to 0 comma 3. Now, this is the curve meeting at 0 and 3. Therefore, we have to integrate from 0 to 3 the area enclosed between the two curves. But for that, there are two curves are there. X-axis is there, and we have to find the formula as y from the upper curve minus y from the lower curve. So, suppose if you want to find the area enclosed by the upper curve, that is the parabola, then total thing will come. Then in area bounded by the lower curve, when you subtract them, you will get the shaded area. Therefore, y from the parabola minus y from the line. From the parabola, it is 2x minus x square. From the line, it is minus x. Where I am splitting the integral into 2. And then I am just adding them. Where I am finding the area. The area is coming as 9 by 2. Let us see the graph of it. It's a very interesting thing. You see, this is the graph, and you are getting 4.5, which is nothing but 9 by 2. It's the area enclosed by the downward parabola and the line passing through the origin. Let us go to the next question. Highly interesting. Here you have been given inequalities for the regions, inequalities for the equations. However, it is the area enclosed between a circle and the line, but a little bit different. Let us see. This is a circle. You have been given area inside the circle less than or equal to 9. Let us go to the line x plus y greater than or equal to 3. All of you know this is the line, but you have to find the area above the line, that is a origin not included. This already you have seen this kind of idea in your linear programming, that is linear inequation. Now therefore we want to find the area common to both. This is the area common to both. Therefore this is the area enclosed. But first you have to identify which is the area enclosed by the given two curves. Well, now this is the area. We already found it. Therefore, it is 0 to 2. All of you know it very quickly from the figure. It is from 0 to 2. But it is y from the upper curve minus y from the lower curve. When you find the region enclosed by the circle, you will get all the area in the first quadrant. Minus y from the lower curve, you will get all the area below the line. Then what will happen? You will get the shaded area when you subtract. This is the idea. Therefore, y from the circle, for all of you know the equation. I am splitting it into 2 for my convenience. I am using the formula for root a square minus x square. Well, I am just substituting upper limit minus lower limit. Here one advantage, some of them will be 0. Therefore, directly you can put 0. Therefore, the final answer is pi minus 2. Therefore, the area is pi minus 2. Let us see it on the graph now. It is 1.14. That is 3.14 minus 2. Approximate. It is pi minus 2. That is the area enclosed by the inside the circle and above the line. Well, solve the differential equation. X into dy by dx into sine of y by x plus x minus y into sine of y by x. All of you please take noted that whenever you are having sine of y by x, cos of y by x, tan of y by x, e power y by x like that, then these types of equations are homogeneous only, whether it is y by x or x by y. Now everywhere you should get y by x, y by x. Therefore, let us try now. For I am just replacing and dividing throughout by x. There I am getting it. Therefore, the equation is minus of y by x sine y by x minus 1 divided by sine of y by x. Homogeneous. Function of y by x. Homogeneous. Be careful. Homogeneous is very easily identifiable when they give sine of y by x, cos of y by x, tan of y by x like that. Okay, well. Now, what is the idea? You know that you have to put y by x is equal to v and dy by dx is equal to v plus x into dv by dx. I am substituting and I am pushing that v to the right hand side. I am getting this equation like this. But here you should be a bit careful. Already, I think you know it. On the right hand side, you will never get x. Everything will get cancelled. Then only you can go for variable separable. I am going for variable separable now. Left hand side is sin v dv, right hand side is minus dx upon x. Integrate. Minus cos v is equal to minus log x plus c. Minus cos of y by x is equal to minus log x plus c. Therefore, log x minus cos of y by x is equal to c. Okay. Now, anyway, I am keeping it ready. Now, they have given you that boundary values. They want particular solution. When x is equal to 1, y is equal to pi by 2. Put it over there. You are getting c is equal to 0. Therefore, log x minus log cos of y by x is equal to 0. This is the solution. Okay. Let us go to question number 14. Solve cos square x into dy by dx plus y is equal to tan x. Here we are getting only one term called y and its power is 1. Therefore, this is a linear differential equation. But for that, what is the condition? Coefficient of dy by dx should be 1 divided by cos square x. I am substituting and then replacing it 1 by cos square as secant square. Now, I am comparing it with linear differential equation of the form dy by dx plus py is equal to q. What is p? Secant square x. What is q? Tan x into secant square x. Let us go to the integrating factor. E power integral p dx, e power integral secant square, which is e power integral tan x. And q is tan x into secant square x. Now let us go to the general solution. This is a general solution. Y into integrating factor is equal to q into integrating factor into dx plus c. Put it over there. Well, now when you see the right hand side integration, you are seeing that it can be done by substitution. Let us try now. Because differentiation of tan x is secant square x dx. Therefore, I am substituting. Right hand side becomes t into e power t dt plus c. Well, this is once again a problem which can be done by integration by parts. You are having algebraic and exponential, which to be taken as u algebraic. Late. Therefore, algebraic to be taken as u. dv is e power t dt. We are finding du. We are finding v. Then we are putting it on the form uv minus integral v du. uv minus integral v du. That is integration is very simple on the right hand side now. Now we have to replace t by tan x. Tan x into e power tan x minus e power tan x plus c. You can take e power tan x outside and then you can give it. Otherwise, you can leave it as it is. Go to question number 15. A semicircular car parking is to be constructed and the equation is given and the straight edge is also given. All of you seeing that what is that straight edge? Y is equal to 0. It is nothing but x-axis. Let us show do it now. Now remember, this is actually from minus 20 to 20. We should not find only the right hand side, that is the first quadrant. If you find only the first quadrant area, multiply it by 2. I have shown both of them over here, minus 20 to 20 y dx, which is nothing but twice 0 to 20 y dx, because the area is symmetric about the y axis. Very simple now. Root 400 minus x square. We are using the formula a square minus x square, x by 2 into root a square minus x square plus a square by 2 sine inverse x by a. Please concentrate on this formula because this formula is highly used when you do integration involving circle and ellipse. Well, I have substituted and sine inverse 1 is pi by 2, sine inverse 0 is 0. I am substituting, I am getting 200 pi square units. But the problem is not over. Let us go to the second part. The second part, now, okay, I will show you the area over the formula over here. It is 200 pi. Now, the second part is find the cost of flooring the car parking at the rate of 500 rupees per square unit. Now, you have to simply multiply the area which we have found by 500. 200 pi into 500. Pi is given as 3.14. When you multiply, you are getting 3,14,000. Well, that is the cost of flooring the car park. For here, very simply, first you have to convert the given equation, visualize it as a curve and then draw it on a graph sheet and then find the area using integration. For that, you should know the lower limit, you should know the upper limit, and we'll show the function. Okay, well, friends, we will continue in our next video. Thank you.